All right, so if you are following along with me, I am on page 17 of your notes here. Okay, and please forgive my typing. I kind of had to MacGyver this together because I'm not sitting at a table at the moment. So, okay, so before we do intervals and tests with difference between means, you have to understand what the sampling distribution for that is. It's very, very similar to what we did with proportions, right? So if you have two populations or treatments and you subtract them, you still have a random variable, you still have a normal distribution, right, that has its own special mean and standard deviation, okay? So you can see on the left side of my screen that the shape for these for this distribution is going to be approximately normal as long as the success fail condition is satisfied. Okay, right? So that's what it says on the left side of the screen, right? Approximately normal if the population is normal or both of the samples are greater than or equal to 30, right? That's the success fail condition. Okay, all right, and then let's switch colors for this one. Let's do a lovely purple color here. Okay, so the center, right, is still going to be the mean. It's not the median, right? So if we're doing a difference of means, it's mu1 minus mu2, right? So subtract your two populations, okay? And then I'm hoping that the spread equation looks fairly familiar to you because we did do this for sampling distribution of differences between means. And it should look to you like all of the other standard deviations we've done, except, right, that we have to deal with variance here instead of standard deviation, right? And the reason we have to do that is because we're adding and subtracting distributions, right? But it's still standard deviation variance over n, right? And see how you have that square root in there. So this spread equation is the square root of the variance, the variance, so that's what this is. So this is standard deviation squared, which is variance of the first population over n1 plus, and then you have to do the same thing for the second population. All right, so standard deviation 2 squared over n2. All right, remember the deal with these is that you're always adding variances. You're never, ever, ever going to subtract variances, right? When you combine two populations or two treatments in any way, right, you're getting more and more variation in there because you're adding another variable in. Okay, all right, so those are your conditions there that you have to meet. Okay, so for the actual confidence interval, it's still almost exactly the same as what you're used to. Okay, it's still this general formula. Okay, the statistic, which here is going to be x bar 1 minus x bar 2 plus or minus the critical value, so that's your t star value, times a standard deviation, which is this spread equation right up here. Okay, the only difference here, we're still going to use our panic, right? PANIC. The only difference here comes in the degrees of freedom. Okay, and the reason that that's different is because we have two populations. So because we have two populations, we have to go with the population or choose our degrees of freedom based on the population that we are the least sure about. Okay, and the one we are the least sure about is always the one with the smaller sample size. Okay, so here for degrees of freedom, you will always use, let me delete right here. You will always use the smaller of the two sample sizes minus 1. Okay, so that's what this says over here that I have underlined in red for you. Okay, that's so the smaller of n1 minus 1 or n2 minus 1. You don't add them together, don't multiply them together, just pick one, and it's the smallest of the two. Okay, and then you have this space down here for the full formula. okay, which I have over there for you on the right, okay, or sorry, on the left, but I am going to write it for you, okay? So here, this is x bar 1 minus x bar 2. So that's your statistic, okay? Plus or minus t star, okay, which is your critical value, times my standard deviation. So remember, we're dealing with samples here, so we're going to use S instead of your symbol up there you see up there at the top in the spread equation at the top, right? Okay, so this is standard deviation 1 squared over N1 plus standard deviation of population 2 squared divided by N2, okay? And if you want to label these, okay, if you want to label these, this is your statistic. All right, so it's going to take me a second to write with this pen. This is your statistic, okay? This T star is your critical value. Okay, and that's the one that comes from the T table. Okay, and then this here is your standard deviation. Right, that is your standard deviation. Okay, and remember, it's the standard deviation of the sampling distribution, right? The difference between those two means. Okay, so those are your basics, right? Remember, the only thing that has changed is that you're going to use the smaller of the two sample sizes that you have -1 for your degrees of freedom. Other than that, you're following the exact same panic procedure, PA and IC. Okay, so I have to clear my screen, right? I have to clear my screen quickly, erase all of this stuff, and then get to the next problem, okay? So there's only one example that I have here for you for confidence intervals, okay? Because we've been doing confidence intervals for a while, so I'm hoping that you'll be okay with just one example, okay? This one, though, I don't give you the summary statistics, I give you the data. So you are going to need your calculator for this one. So I would advise pausing the video real quick and go to the next page and enter the data in your calculator. You will have to enter this data in 2 columns. Okay, so the first column will be the one that says CA. It stands for Chips Ahoy. This is a problem about chocolate chip cookies, right? I know I'm evil over here making you hungry. Okay, so enter the CA data in the first column and then the GV data in the second column. All right, so I'm going to pause this video real quick. I'll see you in a second. All right, everybody. Okay, so here we are at our example. Okay, so this data here, these 2 girls, this is the scenario. These 2 girls have run an experiment. They're trying to figure out if 2 different brands of chocolate chip cookies have if there's a difference in the number of chocolate chips, excuse me, in these 2 different brands. Okay, so one thing I want to talk about for you real quick before I jump into this example is why this is not a paired example, right? So it's not possible to easily pair like one cookie with another cookie, right? So if you look at the way that this data is set up here, okay, these numbers that are in the same column are not paired together, right? Because I could have written these in any order, right? Like, I could have decided this is the order that they pulled the data in. But they could have just decided to write it in numerical order, right, from smallest to largest, or they could have decided to write all of the even numbers first, then all of the odd numbers, right? Like, it doesn't matter what order you write these in. It also doesn't matter what order these down here are written, the GV ones. So what happens, for example, is say I decided to write the top row from from smallest to largest, and then I decided to write the bottom row from largest to smallest, then what's going to happen there is you're going to mess with your data, right? You can't easily pair these two things, right? Because depending on how you arrange the numbers, you could get completely different answers if you pair them, subtract the numbers, and then do a one interval, right? A one sample interval using just the difference column, right? So remember, paired, right, only happens with tests for one, right? So if it's an interval, you know it's either a one sample interval or a two sample interval. This one is a two sample interval because I have two different variables that I'm dealing with, right? The two different types or the two different brands that I'm dealing with. Okay. But also you can't easily pair one cookie with another cookie here, right? Because it's kind of arbitrary. Okay. All right. So this is a confidence interval. So the question is to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. Okay. And remember, the goal is they're trying to figure out, if the generic brand has as many chocolate chips as the name brand, right? So that's gonna basically we're trying to figure out if there's a difference here between these two. Okay, and that's going to come into play a little bit later. All right. So the very first step here is my parameter step. Okay, so we are estimating. And I need to move this to the next slide here because I have a lot of these written out for you already. So we are estimating we're not in the 1600s, the true mean difference between the number of chocolate chips in Chips Ahoy cookies and Great Value cookies. Okay, and what I want you to notice is that I've written over on the slides what each of these is, right? Mu CA and mu, oh, that should say GV right there. Okay, so I'm gonna write that on here for you guys. The only reason I didn't type it is just because it's kind of difficult to get to with the typing. Okay, so you should define your parameter. Like you absolutely should define your parameters so the readers know what they are. Okay, and I'm making this clear for you because, especially because the test this year is only free response questions. This is an easy way to get points and a thing that they'll ding you for if you don't. Okay, so Great Value is mu GV, right? So that's what you're going to see me do for all of these, okay? I'm not going to write out all of the assumptions, okay? Okay, so you can look at the slides to the left of your screen, but you have the three assumptions that you have to check, right? The three conditions. So the first one is randomness. This is random, right? They said they randomly selected 10 bags and 10 bags and then randomly selected one cookie from each bag. So there's like double randomness. We're good on the randomness. Okay. Then the 10% condition comes next. So remember, that's you take 10 times the sample size, which is 10 for both of these. So you get 100, and that's definitely less than the total number of Chips Ahoy and possible Great Value cookies, right? Then the last thing you have to check is the success-fail condition. Okay, so we're checking, is the population normal? Okay, and they didn't tell us anything about that, so we don't know. Okay, and then we have to then check, okay, is the sample size big enough? Sample size is 10 for both of these, which is small, right? It's less than 30. But if you take a quick second to graph all of these out, right, most of these numbers in each one, so the CA numbers and the GV numbers are very close together, right? So there's not going to be any outliers or skew here, okay? All right, so that is your A step. Your N step, right? Remember, the questions you want to ask yourself is, how many samples am I dealing with? And it's 2 in this case. Is it Z or T? Remember, this is mean, so it's T. And is it an interval or is it a test, right? And this is an interval, right? They're asking us to construct a confidence interval. Okay, so this is a 2 sample T interval. Okay, or you could have said, you could have also said 2 mean T interval, because we're dealing with means here. Either is fine. Okay. All right. So that's all of the prep. Let's get to the math. All right. Okay. So here, remember, I did not tell you anything about, like, I didn't give you the statistics for this. Okay. You have to get those by running one variable statistics on your calculator. So once you get to this step, right, once you get to the I step, okay, start by running one variable statistics on the data set, right? Or not the data set, on each data set. Or you can run two variable statistics if you only want to do it once. Okay, so I'm going to show you what that looks like. Okay, so let's go over here to my screen. So I already have these two data sets typed into my calculator. Okay, so if you haven't done that already, take a second, pause the video, okay, enter all of your data. It will be a lot easier to follow what I'm doing if you have the data already entered in your calculator. So I'm going to give you a second to do that. Okay, so I'm hoping that you have all of your data in your calculator already. Okay, so what I'm going to do here, because I have two different variables, notice that I've named mine CA and GV, so it's going to help me later. Okay, what I'm going to do is run two variable statistics, okay, just so that way I only have to do it once. Okay, so I'm going to go over to my menu button, okay, and I'm looking at statistics, stat calculations, and I want this one, two variable statistics. So I'm going to click on that. My X list is CA, my Y list is GV, okay, and then everything else stays the same, and this is where the results are going to pop up. And I'm going to click OK. All right, so here's my two variable statistics. Okay, so if I scroll, it shows me all of the X stuff first. So see, there's X bar for the Chips Ahoy cookies, and there's the standard deviation for the Chips Ahoy cookies, right? So those are the two things I need, X bar and SX. And if you scroll down a little bit, there's the Y, so that's the second variable. So 19.4 was the number for the X bar for the great value cookies. Okay, and then the standard deviation was this, 3.596. Okay, so I'm going to record all of those values. Okay, so I'm going to go back here. All right, I'm going to go back here. I have to switch back to my pen. Okay, so I need to record all of that information, which I have for you right over here. Okay, so I have X bar. Oops, I always forget to switch back to my actual like handheld mouse. It's very difficult to do this with a trackpad on your computer. Okay, so X bar here for my Chips Ahoy cookies was 18.4, not 1.84, so 18.4. Okay, and then X bar for the great value cookies was 19.4. Okay, so remember my statistic, right? All of that together will be this minus this. Okay, all right, but then let's record the standard deviations. So the standard deviation for the Chips Ahoy cookies was 1.774. Okay, and the standard deviation for the great value cookies was 3.596. Okay, so and then the other thing that I need to record is my degrees of freedom. Okay, so my degrees of freedom, since both of these samples are the same size, they're both 10, I'm just going to do 10 minus 1. Okay, you're going to see in the next video that there is one sample that's smaller than the other, right? So you'll see what that looks like when you're dealing with that kind of stuff. Okay, right? And then remember, I'm going to look in my T table for that T star value. I don't have that pulled up right now. Okay, but as a reminder, you read on the left side for your degrees of freedom and then go over to the bottom and look for your confidence level. And my confidence level for this one is 99%. So you would look for the 99% at the bottom, like in the bottom corner, and then see where those meet to get your T star value. Okay, so I did that ahead of time and got T star is equal to 3.25. Okay. So now all that's left to do before I can construct my interval is I need to subtract these two, right? CA minus GV, and then I need to figure out what my new standard deviation is using that formula. Okay, so my statistic here, okay, my statistic is 18.4 minus 19.4. Okay, and it doesn't matter what order you do these in, as long as you, because you'll get a very similar interval either way. You just have to note what you're doing at the top, right? Okay, so 18.4 minus 19.4, and luckily for us, that works out to a lovely, nice whole number, and you get -1. Okay, and then I need to find my new standard error. Okay. Ooh, forgot my equal sign, equals. Okay, so I'm going to take my first standard deviation, which was 1.774, and then I need to square it, right? Because remember, we're always adding variances, right, when you're dealing with two populations. Okay, and then I'm dividing by 10 here. Okay, plus, I need to extend my standard deviation, not standard deviation, my square root a little bit. Okay, so then my second population, standard deviation 3.596. Then I have to square it, divided by 10. Okay, remember the reason we're squaring this, so you remember in the one population ones, you would just take this, whatever it was, the standard error that you got from the calculator, and divide it by the square root of n. Okay, so I have this big square root this time to deal with the square root of n. And so since I really just want standard deviation on the top, the squared and the square root technically cancel each other out. Okay, so that's the reason that that's there, and the way that why it looks so much more complicated than the one sample intervals and tests. Okay, so I go through and I plug all of that into my calculator, and I got 1.264 when I did that. Okay, so now what I need to do is write my actual interval. Okay, so here's my actual interval. Okay, so it's the statistic, -1, plus or minus t star, which is 3.25, times the standard deviation, 1.264. Okay, so that's -1 plus or minus, and then when I multiply those together, I got 4.11. Okay, so that's my plus minus form, right? I have it in both spots, and then I need to subtract 4.11 from -1, and then I need to add 4.11 to -1. So when I did that, I got -5.11 as my lower bound and 3.11 as my upper bound. Okay, so that's my I step. That's my interval. Okay. All right, and then the very last step is that C step, the conclusion and context. I'm not going to write the whole thing out on this side, on the right side, because I have it written for you here. Okay, and I'm running out of space on my screen. Okay, so your conclusion and context, this is your word formula. Okay, so it's we are 99% confident, because that was my confidence level, that the interval from -5.11 to 3.11 captures the true mean difference of chocolate chips in Chips Ahoy and Great Value cookies, right? Because that's what we're trying to find, the true mean difference. Okay, and then I put this note for you here at the bottom. They did not ask this in this problem, but it's a very common thing for AP readers or AP questions to ask is they'll give you a claim, right? And you have to evaluate the claim based on your interval, right? So because 0 is in this interval, that means that there being no difference between those two brands is a possibility, right? And it's a very likely possibility because we said we were 99% confident, right? So we would say that there's not convincing evidence that there is a difference between these two types of cookies because 0 is in the interval. If 0 was not in the interval, so let's say these were all positive numbers, we would say, oh, okay, there is convincing evidence that there's a difference, and we think that the Chips Ahoy cookies actually have more chocolate chips in them than the Great Value cookies. If it was the other way around, if they were all negative numbers, right, 0 was not in the interval and it was all negative numbers, then we would say, okay, yes, I think there is a difference because the interval says that there is a difference because 0 is not actually in the interval. And then we would say, we think actually the great value cookies have more chocolate chips in them, right? Because we did CA minus GV, right? That's what I did up here, CA minus GV, right? So if we get a negative number, it makes sense to say that the great value cookies had more chocolate chips in them, right? So that's how you'd end up with a negative number. All right. So that's it for confidence intervals for two samples, right? For a sampling distribution for the difference of two means. Okay. Exact same procedure, right? Remember, the only difference it really is this, is that you have to just use the smaller of the two sample sizes. Okay. You have to actually subtract your two means, and then you have this complicated formula for the standard error. But lucky for you, it shows up on the formula sheet. Yes, we love the formula sheet. All right. So this is a second to last video in this series for Unit 8. We've got one more. Okay. So stay tuned for two sample tests. Okay. See y'all later.